Hello and welcome to lecture 15 of the Principles of Exercise Therapy PET for undergraduate physiotherapists. This week we take you through the system of systems from the heart to the hormones. There's my Twitter handle at DJWalker587 if you want to contact me directly. Okay, so our centering slide that gets us to focus on what physiotherapy is about. It's about human anatomy and physiology. It's about human movement and function, maximizing wellness and potential, minimizing disease and injury, and ultimately solving real-world problems. So let's just have a quick recap on the cardiovascular system and its 5 important functions. It's going to deliver oxygen to the working muscles during exercise. It's going to oxygenate blood by returning it to the lungs. It's going to transport heat, which is a byproduct of physical activity, from the core to the skin to help cool the organism. It's going to deliver nutrients and fuel to active tissues, and it's going to transport hormones, all of which will increase the efficiency of these system of systems through regular exercise. So the principles of exercise therapy, okay, are as follows. Okay, a little spelling error there. So adaptation, specificity, progression, regression, overload, reversibility, timeout, behavioral change, individuality, lifestyle integration, the law of diminishing returns, and your responsibility. And that's remembered through the acronym ASPORT-BILLY. Okay, they are the principles, commit them to memory. So from this session, we're going to gain insight how to stress hormones affect the body when exercising. We're going to gain insight into how the autonomic nervous system comprises of 2 sets of nerves, the sympathetic and the parasympathetic nervous systems. We're going to explore the overload principle, and we're going to talk about thermoregulation when exercising, all explained in terms of this holistic approach. Holistic meaning the whole person, body, mind, spirit. So what is a hormone? It's a chemical substance produced by the body that controls and regulates the activity of certain cells or organs. It's secreted by special glands, such as the thyroid gland secretes the thyroid hormone in the base of the neck near the Adam's apple, okay, or like a bow tie. So hormones are essential for every activity during life, including the processes of digestion, metabolism, growth, reproduction, and mood control. So many hormones, such as neurotransmitters, are active in more than one physical process. There's a cascade of things that happen. So here we are. Here's the endocrine system. You've got different hormones being secreted. Obviously, we've got the sex hormones, the testes for males, the ovaries for females. We've got the adrenal glands. These will be working with exercise. We've got the pancreas here, regulating insulin and glucagon, which is your blood sugar. We've got your thymus. We've got your thyroid gland, that's your bow tie. And then we've got some stuff happening in the brain from the pineal gland, the hypothalamus, and the pituitary gland. So the neuroendocrine system. Neuro is to do with the nervous system, and this is going to function very quickly. Short-term action is very localized. Endocrine, which is the hormonal system and the glands that secrete these, and these release products into the blood. This is going to function slower, but it's going to have a longer lasting action, and it is generalized in many circumstances. So the neuroendocrine system is a hormonal state that influences the activity of these nerves. So exercise and the neuroendocrine system. So exercise is a robust activator of the neuroendocrine system. It has that dual purpose to provoke short-term and prevent bad things happening to your health long-term. Okay, the importance of homeostasis for the organism being in balance. Okay, and then a disruption to this balance will happen when we have stress, okay, or pain, which will cause stress. There'll be some short-term exposure to exercise training, such as increased heart rate, increased blood pressure. Long-term adaptation to exercise training, such as decreased resting heart rate, increased efficiency of the heart, increased efficiency of breathing, muscle hypertrophy, so on and so forth. And it's that careful balance between undertraining, okay, not doing enough, and overtraining, doing too much. And then, of course, there's thermoregulation. Okay, the body regulating its temperature. So we have got a detailed slide here about what's happening in the brain when we're exercising, what's happening in the lungs, what's happening in the heart, what's happening in the blood. Okay, what's happening? Okay, in terms of the arteries and the blood. Okay, what's happening in the muscle cell? Okay, what's happening in the tissues? What's happening in the organs of the pancreas, the gut, and the liver? Okay, what's happening in our metabolism? Okay, so all these things are occurring while we're exercising. Okay, and you don't need to know them individually, but appreciate that this is a system of systems. So stress hormones. So stress is defined as a real or interpreted threat to the physiological or psychological integrity, i.e. homeostasis, of an individual that results in physiological and or behavioral responses. So the classic one is pain. Pain is a motivator, okay, that will stimulate a stress response. So we've got the autonomic system, and then of that branch of the ANS, we've got the sympathetic nervous system. Okay, so this might be considered your fright, flight, and fight. Okay, we're going to have adrenaline, noradrenaline, okay, adrenocorticotropic hormone, cortisol, testosterone, growth hormone. Okay, all those ones that are associated with stress and exercise. Okay, now we've got a whole list of stress hormones that go on here. Okay, but take particular note of things like cortisol, okay, epinephrine, norepinephrine, growth hormone, and testosterone, because they're going to be the ones that we'll talk about as well. But appreciate that there's lots of hormones going on in the stress response. So as I said before, it's the fright, fight, and flight. Okay, that's the branch of the autonomic nervous system, the sympathetic nervous system. And then the reverse of that is the parasympathetic nervous system, the rest and digest. Okay, this is where you're healing and your body's repairing. Okay, so we've got lots going on. Okay, obviously the brain and the spinal cord. Off from that, okay, you've got different reactions. So a sympathetic, okay, when we've got an adrenal response going on, the pupils are going to dilate. Okay, you're going to have a decrease in your saliva because we're not going to be resting or digesting as well. Heart rate's going to increase. We're going to get ready to breathe deeper. Okay, so peristalsis stops, so your gut stops, so you're not going to need the loo because you've got to do stuff. Your liver's getting ready to convert glycogen to glucose. Okay, so we've got adrenaline going there, and the bladder is inhibited. Okay, so all of these things going on. Okay, and the rest and digest. Okay, when we're chilled out and relaxed, there's going to be increased saliva, your heart rate slows down, your bronchi constrict, okay, peristalsis can happen, so you can go to the loo, okay, you can have stimulation of bile, okay, and your bladder can contract and relax. Right, so we have an acute response to stress hormones. Okay, so this, as soon as we start getting ready to exercise, we're going to have an increased breathing rate, we're going to have increased blood flow to the skeletal muscles, increased heart rate, okay, blood sugar is going to increase, getting the nutrients ready to be used, blood pressure will increase, the pupils will dilate, and the intestinal muscles will relax because they're not needed. This is the acute response to stress. Okay, and these are really good for us as well. So it's going to help control our weight, it's going to increase our self-esteem, it's going to give us more energy, it's going to give us stronger joints and bones, it's going to help with metabolism, healthier heart, reducing blood pressure, strengthen the immune system, improve self-image, tone muscles, and stress relief. So this is all the good stuff, okay, of that long-term adaptation from stress. Okay, now if we're under stress for too long, okay, this is overtraining, okay, or in the case of exercise, you're overtraining. So what's going to happen is you're going to be ill more frequently because you can't recover, okay. There has been links to things like cancer and depression. You could have skin disorders like eczema, okay. You could also, if you've had a traumatic event, you could suffer from PTSD, you might get stomach ulcers, you might get heart disease, you might have a reoccurrence of your asthma. All these happen when you've been exposed to stress for too long. Okay, and this is what happens is you get stressed, Okay, reduce circulation, muscles get tight, increase muscle tension. We have all that going on. That's going to put pressure on the nerves. It's going to restrict the movement, going to lead to pain, and we go round and round in this. And this is called the pain cycle. Yeah? Okay, you're in pain, so your muscles get tense, so you don't move, so you've got poor circulation, restricted movement, pressure on nerves, you're in pain, and you go round and round and round and spiral downwards in the pain cycle. So coming on to overload, healthy overload. So that's going to refer to training intensity of the exercises that you're given. Okay, so we're going to talk about things like load. We're going to talk about the speed or the intensity. We're going to talk about the distance, the volume, and the rest intervals. Okay, so if we provide a greater stress on the body than it's accustomed to, then it's going to have an adaptive response in the long term. So the human body is involved in a constant process of adapting to the stresses or lack of stresses placed upon it. Okay, so when you stress the body in a manner it's unaccustomed to, you create an overload. Okay, and you do that repeatedly, and you're going to get an adaptation, a change, and you're able to handle the stress in a better way next time. Okay, but don't be upset by the results you didn't get with the work you didn't do. Okay, so that's an important one to realize. Okay, that just because you're thinking about exercise doesn't mean you're actually doing it. So the overload principle, we use the FIT principle. Okay, frequency, intensity, time, and type. Okay, so here we've got a healthy overload. Okay, so we've done our training session, you get a dip. Okay, and then you heal greater. Okay, next training session you get a dip and you heal greater. Next training session you get a dip and you heal greater. Okay, if you've got too much load, what happens is you do your training session and under recover. Okay, so you do another training session, under recover, and then here you're spiraling downwards. This is an inappropriate level of overload. Okay, so we talk about exercise as a drug and it requires a specific dosage. So the exercise dosage, the way we remember it is DRIVE, the acronym DRIVE. So the duration, the rest and recovery, the intensity, the volume, and the energy system that predominates. Okay, we then talk about things like the SAID principle, the specific adaptation to imposed demand. Okay, so local muscles, the heart, energy system, the movement pattern, and the components of fitness, they're all going to come into play on this. So remember that the dosage must be sufficient to create an overload. So we've got to do it faster, we've got to do more, we've got to do it longer, and we've got to do it more often, okay, and potentially with less or more rest in order to develop this long-term training effect. So if we're overtraining, so the symptoms of overtraining you've got to watch out for. So decreased performance, decreased strength, increased muscular soreness, chronic fatigue, this is a big one to look out for, or tired all the time. Okay, reduced tolerance to training overload, disturbance in your sleep-wake cycle, okay, disturbances with your tummy and your digestion, reduced sexual drive and libido, altered heart rate responses, and suppressed immunological function. Okay, the psychological effects can be worse. Okay, feelings of depression or anxiety, lethargy and apathy, emotional abnormalities, loss of appetite, lack of competitive drive, restlessness, difficulty in concentrating, and this is also beware of exercise addiction, people that depend on exercise for their high rather than, they're abusing the drug of exercise. So sleep is massively important, okay, because it's your rest and recovery stimulating that parasympathetic nervous system. You need between 5 and 8 hours per night, depending on what's good for you. We used to sleep more, we now sleep less, okay, particularly in the West, with technology and looking at your phone or your laptop late at night, all that sort of stuff. There's a strong link between lack of sleep and obesity, because when you feel tired, you're more likely to snack on sugary substances, okay? So this is called neurobehavioral influence, so you're going to eat more if you're tired, or neurocognitive influence, okay, you're going to abuse stimulates like cans of high doses of caffeine, okay, like Monster, like Red Bull, okay, or lots of coffee. So sweating. So your autonomic nervous system controls your sweating function. This part of your nervous system that functions on its own without conscious control. Okay, so you can't control your sweating, but you can control things like your breathing. So when the weather's hot, your body temperature is going to rise and sweat is released through the ducts in your skin. It's going to moisten the surface of the skin and cool your body down as it evaporates. It's a bodily function that helps regulate your body temperature. It's also called perspiration, and sweating is the release of salt-based fluid from your sweat glands. So temperature in your body changes, the outside temperature, and also your emotional state can induce sweating. Okay, things like if you're scared of spiders and you see a spider. So most common areas for the body of sweating include the armpits, the face, palms of the hands, and the soles of the feet. So here we've got increase in your temperature. Okay, so what we're going to do is the skin vasodilates. Okay, and we're going to reduce that. Okay, if you're cold, you might start shivering and you get vasoconstriction. Okay, and it's all about either heat gain or heat loss to maintain that equilibrium. So heat, stress, and exercise. We are meant to sweat. We're designed to sweat. It's an independent process of respiration. The human ability to sweat is our most important adaptation, as it allowed us to run and hunt in the hottest parts of the day when other animals couldn't handle the heat, because panting is inefficient. So early persistence hunters would run their prey literally to exhaustion and overheating because they could run during the day because humans could sweat. So this evaporative cooling, the majority of mammals have it, including humans, and they rely on the skin, the moisture evaporating from the skin to cool it down. Where this doesn't work so well is in really humid climates as well, where the skin can't evaporate. Perspiration can't evaporate off the skin. So we talk about that holistic approach. The whole person is considered. So what they do for a living, how much sleep they're getting, and what activities they're doing, their nutritional status, their hydration status, and obviously their mental health status being probably the most important. So by the end of this lecture, we have described what a stress hormone is and how it affects the body, both acutely and chronically. We've explained how exercise affects both the sympathetic nervous system and the parasympathetic nervous system. We've described the overload principle. We've talked about the importance of sweating and how it's regulated. And we always remember to deal with everybody we come across in a holistic way. Thanks for listening, and we'll see you in the next podcast.